Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, I'm Dr. Joseph or Mr. Explicit. Please, as you watch this video, endeavor to subscribe, like, share, and comment. In our previous class, we discussed fundamental and derived quantities. I gave you the various examples of fundamental quantities: mass, length, time, current, temperature, luminous intensity, and quantity of substance. And I also gave you that mass is measured in kilogram, length is measured in meters, time is measured in seconds, temperature is measured in Kelvin, luminous intensity is measured in candela, quantity of substances is measured in moles, that is moles, small letter what? N. Then current is measured in ampere. And I also give us some examples of derived quantities and their formulas. So on the board we have two questions that we are to solve together. The first one says, the dimension of magnetic flux is dash. I do not know. So let's deduce it. Magnetic flux, all right, is given as force times area over charge times what? Velocity. All right, velocity. Now, force, before I deduce, before I start to slot in my alphabet, let me deduce for them separately, okay? Force is what? Mass, or let me do for acceleration first. Acceleration is what? Or let me do for velocity first. Yeah, I have to do for velocity. You see the reason very soon. Velocity is giving us what? Distance over what? Time. If this t goes up, it becomes LT minus what? 1. Alright, that is what? Velocity. Now, acceleration is what? Change in velocity over what? Time. Alright, velocity as deduced is LT minus what? 1 over what? T. As soon as this t goes up, it becomes minus what? 1. So I have LT minus what? 2. That is what? Acceleration. Okay. Now force is mass times what? Acceleration. So mass, I told us we are using the first alphabet, big letter M, times acceleration, LT minus what? 2. So which means that from here I have it to be M LT minus what? 2. Alright, so with what I have here, we can now slot in all these alphabets. Now, magnetic flux, we have force. Force is MLT minus 2. Area is length times length, and that is what? L squared. Charge is IT. I connotes the current, then T connotes what? Time. Velocity is what? Where is velocity? L T minus 1. You can see the reason I deduce it first. L will go into L, I'm left what? L. Alright, so from here, I have M. L times L, I have L squared. Alright, there's an invisible plus 1 here, right? Is that not correct? So plus 1 minus 1, it is nothing, alright? So I'm left with what? I, just I. So don't forget you have T minus 2. As soon as this I goes up, it becomes I minus what? 1. This L will go into one of the L's here. I'm left with what? 1L. Plus 1 minus 1, nothing. So out, I'm left with what? I, which is current. If this I goes up, it becomes what? Minus 1. So the dimension of magnetic flux is ML squared T minus 2 L minus 1. The answer should be there. Okay, in this case, you know we said that current is measured in ampere. Alright, so they used ampere, A. Alright, so wherever I see I, I'll put what? A. Therefore, the answer is ML squared T minus 2, then A minus what? 1. B becomes the answer, right? Take note of that. It is very, very important. Now, number 2, the dimension of electromotive force is dash. Electromotive force can be defined as the work done in carrying a unit charge from the point of infinity to a considerable point. In other words, it involves it is a work done in carrying a unit charge from a lower potential level to a higher potential level. Alright, so electromotive force, that is E.M.F, is giving us what? Work done over what? Time. Work done, in carrying a unit charge. Yeah, charge is what? Q, right? Work done is force times distance. Let me use L. Charge is what? I.C. Yeah, you see now. So they are using I in this case. So we are going to be using what? I. So work done is, let me deduce it separately. Force times distance. Force as initially deduced is MLT minus 2 times what? L. So I have here L times L squared, then T minus 2. I told us in our previous class that work done, moment, torque, Boy's law all have the same dimension. I take it again. Work done, Boy's law, moment, torque, they all have same dimension as ml squared t minus 2. This becomes the answer of what? The work done. Or this becomes the dimension of what? Work done. Now, from what I have done so far, it means that EMF, work done is what? ML squared T minus what? 2. Then we said that current is what? IC. So I times what? T. As soon as this T goes up, it becomes what? Minus 1. Therefore, I'll say M. This L squared is still there. It's not being affected. L squared. This T, once it goes up, becomes what? Minus 1. So I have what? T minus 3. Then I, once this I, which is the current, as soon as it goes up, it becomes what? Minus what? 1. Our answer becomes ML squared T minus 3, I minus what? 1. So is the answer there? ML squared, so D becomes the right answer. Please, if you know you have learned something in today's video, subscribe so that when I upload more videos on dimension and other topics, you'll be notified by YouTube. Thanks for watching. Do have a wonderful day.